So hello guys, I am Ranjan Miliberos and today we will do experiment 9, Boolean algebra logic circuit simplification. So we have here our diagram. Next is our materials, which are the AND gate, OR gate, the resistors, LEDs, and the switch. So now let's try to simulate and construct the given diagram. First, we have the AND gate, switches. So as you can see here, I've connected this to pin 13 and 12 given in the diagram. Next, let's connect the LED are in 1 and in. Now, I've connected the switch 1 in to D1 and D2. Next, go to the AND gate. Let's next in D1, D2 to pin 1 and 2, which are shorted, and pin 4 and 5. So, as you can see here, I've shorted pin 1 and 2 and pin 4 and 5 and connected switch D1 to any of these pins. This is shorted, and D2 any of the pins. Next, let's connect the output pin 3 and pin 5 to the pin 1 and pin 2 of the OR gate. Now, we have the input for the OR gate using the output of the NAND gate. Next, let's connect the output of pin 13 and 12, which is pin 11, to the input pin 13 and 12 of the NAND gate. Next, let's connect the output of the NAND gate pin 11 to in 3, which is an LED, and the output of the OR gate pin 3 to in 4, which is also an LED. As you can see here, I've already connected the output pin 11 to the LED of NAND gate, the output of the OR gate pin 3 to another LED. Let's show the LED. Let's see here. Here's the LED. Let's move this. Next, let's supply the ICs. First, let's connect them. So let's connect the pin 14 to the VCC, pin 7 to the ground. Also for the rest. Next, let's try to supply it using a power supply. The output. So now we have here table. So switches D1, switches D2 are directly connected to in 1 and in 2. So no matter what we on D1 or D2, since D1 is connected to in, let's say input 1 on D1 have 1 output on in. D1 is 0. We have 0. So in D2 is 1. We have 1 for in 1. Next is in 2. We have 1 on D2. We have 1 on in2. We have 0 on in2. We have 1, 0 on in2. Next, for output in3 and in4, we'll have to explain our output. Next, as we can see here, the output for in3 is AB bar, and the output for in4 is A bar plus B bar. So let's try to solve it. So we have here A B bar, let's add bar. Now, using the Morgan's theorem, let's remove this long bar and change the operation for it to be removed to addition. Since it's multiplication, let's change it to addition. Then add individual bars. So here's our final output. So as you can see here, the output for in3 and in4 is the same. Now let's try to solve it using the inputs. So we have 0, the input will be inverted, and 1, so 1, 0, 0. That's for A. Next we have B, so we have 1, 0, 1, 0. The inputs, so you can see here, so 0 is inverted to 1, 0 is inverted to 1, 0, 1 is inverted to 1, 0, 1, 0, 0, 1, 1, 1. Now let's try to use the addition. We have 1, 1 plus 1, 1, 1, 0. So we have here 1 plus 1 is equal to 1, 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, 0 plus 0 is equal to 0. So here's our final output. Let's try to check if it's true on the simulation. So here, let's try to simulate. So 1 plus 1, and let's start to 0. So 0, 0 is equal to 1, 0, 1 is also equal to 1, 1, 0 is equal to 1, then 1, 1 is equivalent to 0. So there we have it for our experiment. I hope you understand. Thank you for watching.